Elizabeth.
And I'm Austin,
And we're going to teach you about the gas chromatograph.
also known as the GC.
So the first thing that you need to know is how to turn it on. So the first step would be to turn on your three gases, which consist of compressed air, hydrogen gas, and helium. The second thing that you need to do is turn on the instrument itself. To turn on the GC, you hit this button, and then you turn on the computer. So once you have the computer on, you open the instrument icon, and here you can see that the computer and the GC are talking to each other and getting set up. Okay, so once the system is up and ready, you want to load a method. So we go to Method, Load Method, and the method that we want to use is already there. It's fong.m. So then you just click OK. And then once you have your method loaded, you are going to go to Run Control and Run Method. So what you can see here is it says that it's waiting for the injection, so you are all prepped and ready to go. So the next step would be to look at the front of the GC. You want to make sure that the not ready light is off. And once you know that it is not on, you are ready to go. So the first step would be to actually hit Prep Run. Then you would see the Prep 1 light come on. Once it is held steady, then you can go ahead and inject your sample into the injection port and then hit Start.
Go.
So next we'll talk a little bit about the flow of the instrument, and you start by injecting here in your injector port, and next the carrier gas will carry it down into your oven, which if you look in here, contains your column. And the oven is important because this is what produces your thermal ramp, and your thermal ramp will start out at a lower temperature to stabilize your column, and then it'll increase generally around 25 degrees Celsius per minute until it reaches a max temperature where it levels out to purge the system. And you should know your max operating temperature for your to set your oven maximum temperature, because if you go above your max operating temperature, you'll start to delaminate the stationary phase on your column.
If you start to delaminate your stationary phase on your column, you can actually see that in your chromatograms. You will see peaks that will pertain to what the stationary phase is actually consisting of. So if it was a siloxane column, you will see siloxane peaks. You can find the MOAT or MOAT for your column right on the column itself generally. So the reason why your thermal ramp is so important is because it provides you with SSS, or sharp, separated, symmetric peaks, which is what you will find in your chromatogram. Okay, so as you can see here, this is one type of column. This is considered a glass open capillary column. There are also metal columns or glass columns. Both can be packed. And generally you would pack them with either silicone powder or diatomaceous earth. The type of column that you're going to use, though, just depends on what you're actually running through the GC and what you're testing for. So with these ones here, the open capillary columns, your stationary phase isn't packed inside. Instead, it is painted or coated on the inside of the column itself.
And when you inject your sample into the injection port here, it travels into the column, and it will stick to the stationary phase, and it will release and then reattach to the stationary phase all the way throughout the column. And it's almost like a jumping pattern. And these are particular to each compound, and this will produce your retention time, because different compounds will stick and release at different points. And your retention time would be from the time it takes to travel from the injection port through your column to your FID detector.
So following that pathway, it goes through here from the injector, down into the column, around, back up, and out into here. This right here, this back portion, is where you would find your detector. Okay, so gas chromatographs can utilize different detectors. Here at Alfred, we use FID detectors, also known as
Flame ionization detectors.
Now these detectors are useful for just about any compound except for heavy aromatics, herbicides, pesticides. You can use them for ketones, aldehydes, alkanes, small aromatics. And like I said before, the detector is located back here. But you can also use other detectors. PID detectors are great for aromatics, whereas MSD detectors would be very useful within a forensic setting to do drug analysis. And then you have another detector, the ECD, which would be very useful to agricultural departments because they test for herbicides and pesticides. Okay, and now that we've gone through the basics of how the GC works, we're going to show you how to actually do a run. So the first thing that you want to do is make sure that your method is loaded, which we already have done, and then you're going to prep your run. Now, as you can see here, the prep run light is on and it is stable. So what he's doing here is he is prepping a wet needle. So he is putting the needle down into the solution, and then he's going to inject it into the port.
I think so.
Okay, and as soon as you inject it in, you hit start. Okay, and as you can see here, it has started. Where this red line is shows you where the run initiated. Okay, so as you can see, the run has completed. The screen tells you that it is no longer ready for another run, as well as the front of the GC also has the not ready light lit. So this tells you do not inject another sample. Okay, so after the run, we ran a 1:1:1 reference mixture for the alkanes, which consists of hexane, cyclohexene, and octane. And this right here is the resulting chromatogram for it. Now with each run for the GC, your retention times may vary just a little. So these right here, these are the peaks that we got. And there's just one final thing that we would like to know about the GCs here. As we've mentioned before, you can have specific columns for specific types of things that you're trying to detect, such as aromatics or alkanes. Now, Lisa is the one that we were running on today. She is great for analyzing alkanes and ketones. This GC here, his name is Bart. He is great for analyzing alcohols and ketones. And then we do have a third GC here at Alfred. Her name is Maggie, but unfortunately, she is not in working order. So that was it. That was our explanation to you as to how to run a GC, as well as all of the ups and downs of gas chromatograms. So this is Austin saying he's out. Thank you for watching.